Say again.
Do you ever just take 2 photos? That's something.
No.
One at the start, one at the finish, because you forget to put it in record.
Oh, no, I've never done that before. What does that help you stop? Remember to record it or something?
No, that's what my dad does. He tries to record me doing something, just takes a photo at the start and a photo at the end.
I love the one whenever anyone wants to take a group photo, you sit there and you go, line everyone up, get them all there, and you take it and you go, oh, hang on, it was on video mode. Make them all go back to where they were and put it on video mode. Alright, so today we're going to have a look at 2b and 2c. So 2b is zeros, roots and factors of polynomials. So just to reiterate on at the end of our PMI test, just a little bit about polynomials. Polynomials are any equation of form ax to the power of n. So the variable, all right, is our number here is our base, and n can take any power, right? So the leading power is x squared, quadratic. If it's x cubed, cubic. X to the 4, quartic. Okay, that's what we learned up to in Year 11 methods, and that's pretty well all we really deal with. Occasionally you will get ones raised to the higher power, but for the sake of this chapter they tend to be x to the 4 at most quartics. Very good. Now, just a bit of language. We're going to use the words roots, zeros, and x-intercepts to mean the same thing, okay? So a root is where the function crosses the x-axis. We also use x-intercept to describe that. And a zero is a number that you would put into an equation that makes it equal to 0. Okay, so all of those mean the same thing. Be familiar with that. Roots, zeros, x-intercepts all mean the same thing. So that's the first thing to say. And anything else about polynomials? We have x to the power factor. Okay. So if p is a root, okay, if p is a root of a polynomial, then x take p is a factor. We can pull that out the front of that polynomial. That's what we're going to be applying to that. P is a root, then x take p is a factor. And we saw that pop up in Year 11 methods semester 1. When we have these kind of graphs, right, you know, look, I've got this cubic equation here, I can see that this is a root, minus 2 is a root, so that means x take minus 2, so x plus 2 is going to be one of the factors of that cubic. Does everyone remember that? So this cubic would be x plus 2, x take 0, x take whatever that number corresponds with. Okay, that's what's going to be popping up a little bit today. All right, let's get into these examples then. That text up the front there, if x take a is a factor, we can talk about that a little bit later when it pops up. That's sort of alluding to the p, if p is a root. And if a is a 0, then p of a is 0. All right, we've got the equation 6x squared plus 5x, take 4, sorry, I should just say the quadratic. It's not an equation because it doesn't have an equal sign, it's a quadratic expression. Now we're asked to find the zeros. Now to find the zeros, that means find the values of x that would make this equal to 0. Okay, it means find the x-intercepts, it means find the roots. So we've got a number of strategies we could use, a plethora of strategies we could use. We could go straight to quadratic formula, that foolproof algorithm that will always give us a solution. We could go to our calculator, graph it, and g-solve the roots. We could go to equation solver, type in a polynomial. We could complete the square, we could factorize it. There's lots of ways we could factorize it. There's so many ways we could go about solving this. Let's go ahead and factorize it. I'll talk about 2 factorization processes. The first we're probably familiar with is called the cross product method. And in order to do that, what we need to do is we need to go, what are the possible combinations of 6x squared? So we could have 6x times x, and we could have 3x times 2x. They're the possible ways we could get 6x squared, right? What are the possible combinations of minus 4? Well, we could have minus 2 and positive 2, or we could have, I might write them up all in a row actually, or we could have 4 and 1. And we could have 3x and 2x, and we could have minus 2 and 2, 3x and 2x, and we could have 4 and 1. And the order of these does matter. So the problem with the cross method is we need to investigate a lot of circumstances. The more you do it, the faster you get at doing it. And the way the cross method works is you're just going to cross multiply, okay? X times minus 2 would give me minus 2x. 6x times 2 would give me 12x. And when I add these together, I get 10x, okay? 10x is not what we have in the middle, so that means this is not our solution. So we keep going, we've got to go through these to identify what's the solution. And you get really fast at doing them in your head. So we have 4x plus, no, I need to make one of them negative, don't I? So just make the 4 negative. I need to make one of them negative because minus 4 times 1 is minus 4. So here we would have, minus 4x plus 6x would give us 2x. That's not our solution either. Here we have minus 4x, and we have plus 6x. That gives us positive 2x as well. That's not our solution. Here we would have 8x and 3x. Now this can be useful as well. I haven't assigned a negative, and I know I'm looking for positive 5. So if I've got 8x and 3x, I want to make that the negative one, right? 8x plus negative 3x would give me 5x, which means this is our solution. I've made the 3x negative, so the negative belongs there. 3x times minus 1 gives you minus 3x. 2x times 4 gives you 8x. So this is our solution, right? We've identified it by going through all the possible combinations. It's a little bit annoying. What we'll do, we wrap the brackets around horizontally. So we have 3x plus 4 multiplied by 2x take 1 is equal to 0. Okay, apply the null factor law. 3x plus 4 is 0. Or 2x take 1 is 0. 2x is 1, x is a half. And then over here we'll have 3x is negative 4, x is minus 4. Okay, so really all of this is just me brainstorming, me trying to identify what's the factors. Okay, you don't get any marks for expressing that. We can go from there straight to there, and then we're applying the null factor law. So that's one factorization procedure we can do. That's the cross method. That's what tends to get taught in year 10 and year 11. However, let's just talk quickly about types of polynomials. You can, quadratics even. You could have something like this, x squared plus 3x plus 4. This is called a monic quadratic trinomial. It's monic because this number out the front is 1. This is called a non-monic, okay? Because the number out the front is not 1. And when we have non-monic quadratic trinomials, they get harder to factorize because there's more possible combinations. So one procedure we can use is called the slide method. And Seth knows this one, I know that much. I'm sure some of you other guys have seen it too. But if we have 6x squared plus 5x take 4, we want to factorise this. What we do is we slide this 6 over here. Okay, so in my next step, I'm going to have x squared plus 5x take away 24. 6 times 4 is 24, and we keep the negative there. And now we've got a monic quadratic trinomial to solve, right? And we're looking for numbers that multiply together to give us minus 24. Product is minus 24, and the sum is positive 5. All right, and positive 8 times minus 3. All right, we have positive 8 times minus 3. That will give us minus 24, and we have positive 8 take away 3. That will give us 5. So this is what it factorizes to. So I'll put that in the next step. We're going to have x plus 8 and x take 3. So we identified those, right? But we multiplied that 6 through, which means we need to try and divide both of these parts of it by 6. So if I'm putting on top of 6 here and on top of 6 here, so 8 on 6, the simplest way I can write that is 4 on 3. Over here we have 3 on 6, the simplest way I can write that is half. And then this, because that doesn't divide, this number comes up here. So we have 3x plus 4 and 2x take 1. And then we apply the null factor law as we did. So this can be a little bit easier because you don't have to entertain so many possible combinations. Now, if this is a skill you want to practice, let me know. Or if you want to practice this one, let me know. I've got so many of these that I can hand out for you. But you have your calculator from now on as well, so you can easily reverse engineer an answer. we might entertain that in a moment. So find the zeros. There's our two answers right there. They're the zeros. Okay, happy with that? All right, so let's move on then to the second one. We have z to the 4 plus 2z squared take away 3. Now, what type of polynomial is this?
Quartic.
Quartic, because it's the leading power, the highest power is the power of 4. Very good. Now, we're trying to find the zeros, aren't we? Now, looking at that, that's a little bit tricky for us to factorise. Okay, I don't really know how to factorise quartics. I know how to do quadratics, but quartics are really tricky. So we've always got to look for ways of simplifying things. One thing we could do here is let a equal z squared. Okay, a is z squared. So now z to the 4, that is z squared squared. So if I'm going to rewrite this expression in terms of a, we have a squared plus 2a. Okay, and now it's a quadratic, right? So if a is z squared, I'll just write this here, z squared squared is z to the 4, right? And a is what z squared, so I'm putting the a in there, and we have a squared. So I'm just writing this expression in terms of a, and now we can factorise it. We're looking for two numbers whose product is minus 3, and sum is positive 2. So factors of minus 3, 3 and 1, and we have to make one of them negative. We make the 1 negative, so that we have 3 plus minus 1, give us positive 2. Okay, so that means our roots are a take 1 and a plus 3. Now a was, now we can put a back in, a is z squared, right? Z squared take 1, z squared plus 3. Let's apply the null factor law. Okay, a times b is 0, either a is 0 or b is 0. Solve. All right, now I might talk about that last part there. So we have 4 roots here, and you can expect a quartic, z to the power of 4, has up to 4 roots. Not always 4, sometimes it'll only have 1, sometimes it might even have none. But a quartic will have between 0 and 4 roots, and then we'll have 5. And you can see we've got 2 roots here, and the 2 roots here. Now this is the extent of complex numbers that you're required to know for this part of the Year 12 spec, for this test. So let's just break down, what did I do there? I've got z squared is minus 3. So I'm square rooting both sides, right? So that's going to give me z is plus or minus the square root of minus 3. Now one way we can write that is that's plus or minus root 3 times root of minus 1. And what is minus root of minus 1 but I, isn't it? Okay. Now that I is outside of the root, so you can put it in brackets if you want, or you can put the I in front, but do not have that I tucked away inside the root. That would make your answer wrong. So you have to be careful about those things. Really good. So that's B. Let's go to C. All right, and in C, this is where we're applying the principle that we learned at the top. So we have find all cubics with roots 2, 3 plus, and 3 plus or minus I. So a cubic has up to 3 roots. Now we're asked to find all cubics. So this is just how we're going to start it, right? The first is that we've got A out the front. We don't know what A is. A is the dilation factor. It could be any number. Because we're finding all cubics, we just denote A as some real number. And we'll express that in a moment. Now, we have a root of 2. Now, remember we said if P is a root, then x take P is a factor. We have 2 is a root, therefore x take 2 is a factor. That's the first part we have of our cubic polynomial. Then we've got to multiply it by something else. Now the other thing we're told is that the other roots, we've got two more roots. These are 3 plus I and 3 take I. Now you would be perfectly justified, right, in saying, okay, if that's the root, if that's another of the roots, then we're going to have x take away 3 plus I. Okay, remember, if p is a root, then x take p is a factor, and x plus, still x take 3 take I. Okay, so we've put that root there, we've put that root there, and the first root was 2. You'd be perfectly justified, that's fine as an answer. However, we can make this look a little bit nicer. So, for a quadratic, if we have a quadratic that has roots, let's say q and p is roots, okay? If q and p are roots of a quadratic, then p plus q is equal to minus b, and p times q is equal to c for some quadratic x squared plus bx plus c. Okay, so we're going to use that principle now. If p and q are roots, then the sum of the roots is minus b, and the product of the roots is c. That's 11 method semester 1, sum and product of roots, so read that. So if I add these roots together, 3 plus I, plus, so that's my first root, 3 plus I, plus 3 take I, what are we going to have? 3, 6, good. 3 plus 3 will be 6, I take I will cancel. We're just left with 6. And if I multiply the roots together, I have 3 plus I times 3 take I. Anytime you can see difference of two squares, apply it straight away. A plus b times a take b, it's a squared take b squared. Okay, I squared. Let's break this down slowly for this part. That'll be 9 take the square root of minus 1 squared. What is I but the square root of minus 1? And so when I square the square root, that just gets rid of it. So we have 9 take minus 1. And 9 take minus 1 is 10. Okay, so what we saw is the sum of these roots is 6, and the product of these roots is 10. So, one way we can now express this cubic, we can write it like that, that's fine. They're what we call the linear factors, right? But we can express it as a factor of a linear and a quadratic component. X squared take 6x plus 10. Okay, so I'll just point out, how did I get that? Okay, the sum is minus b. We saw the sum of the roots was 6. So that means I need to put minus 6 in front of the x. We saw the product of the roots was 10. So that means my value of c for the quadratic is 10. If you go ahead and use quadratic formula to find the roots of this quadratic, what would they be? This quadratic here. 3 plus I and 3 take I. I've said these are the roots, okay? The sum of the roots, the product of the roots give us this quadratic. Therefore, if you find the roots of that quadratic, these would be your answers. All right, let's stop there. So, 2b, let's spend a bit of time on that, see how we go. And